So this section is going to talk about mathematical modeling. Mathematical modeling is a process where you have some kind of real-world problem. So we're going to start over here at the real-world problem. So you might have something where you want to find out, just because we've got it now, we want to find out how much the coronavirus is growing per day. And we might want to model it. So we would actually be able to come up with some problem to where we're going to be working with that. And then based on that, we formulate a mathematical model. A lot of times the way we formulate that mathematical model is we actually take that data and graph it and look at the graph to see what kind of graph does it, what kind of function does it look like it matches. And so one of the things that we do is we want to understand what the different function models we have, so we know how to mathematically model it. And then when you do that, you have a lot of parameters you have to figure out, and that's what the solving part would be, is where you kind of figure out what those parameters would be through a process of, usually it's called what's called regression, where we try to take that data and come up with this model, but you have to know what kind of function you're going to start with. So that's why it's important to have an idea of what the functions are first, and then we can come up with a math conclusion of what we think it is. But just because we think that's what the function is doing doesn't mean that's what it is. So we then use that function to interpret, making a real world prediction of what we think is going to happen. And then we test to see, does that actually fit the problem we were dealing with originally? And if it doesn't, then we start the process again. And even if it does, we still go through the process again to better the model and come up with better information with the more data we collect. So this is the process where you go through to come up with equations and come up with these functions. So it helps us to understand what these functions are. So we're going to look at the different types of functions that exist. So the first function that we have is what is called a linear function. And a linear function is anything that's of the form f of x equals mx plus b. In other words, it's changing by a constant amount. That's the slope, that m. Your variable changes by the constant amount, and then you shift it up or down with this plus b. So this is known as a linear function. A polynomial function is a function that would be like f of x equals, and I'm going to give a simple one, but they all change from this, a x to the n, call it a n x to the n, plus a n minus 1 x to the n minus 1, plus a n minus 2, x to the n minus 2. And this doesn't look very simple, but the idea of those n's are integers. And you can keep going from here. And then we're going to keep going down till we get to a sub 2 x squared plus a sub 1 x plus a sub 0. A sub 0 is a constant term. A sub 1 x is your linear term. So basically a linear function is a polynomial function. We like to call them something different, but they're really not. They're just polynomials that stop at degree 1. Quadratic stops at degree 2, and so forth. So this is known as a degree n polynomial function. The a sub n's are just your coefficients, whatever number is that describes it. We also have a power function. A power function is a function that would be just some number, let's call it a, x to some power n. Up here, these n's have to be greater than or equal to 2. All right, so these are all going to be integers. Polynomial functions, all your powers are integers. With a power function, your powers don't have to be integers. The only thing n can't be is n can't be, actually, n can be anything. So actually n can be anything, sorry. So this is known as a power function. It would be like ax squared, or ax to the 1/2, or ax to the minus 5, or even ax to the 0, ax to the pi. That n can be anything you want it to be. A rational function is a function that is the division of two polynomials. So you might have p of x over q of x, where both p and q are polynomials. All right, so as long as it's a polynomial on the top and a polynomial on the bottom, it's known as a rational function. An algebraic function is actually just combinations of these. They're either additions or subtractions or divisions or roots of these, of all these. So these are just combinations of polynomials and power functions. So if something like f of x equals the square root of 4x squared plus 3x plus 9 is a algebraic function because we have a polynomial inside of a square root. So that's what we call as a algebraic function. There are other functions that exist in the world. You've seen these in the past. Trigonometric functions are functions like f of x equals the sine of x. G of x equals the cosine of x. H of x equals the tangent of x. So these are these kind of functions, these trigonometric functions. We also could have their inverses. So you could have the inverse sine, inverse cosine, inverse tangent. You can also have the reciprocal functions like cosecant, secant, and cotangent. We don't work with them as much as we do the sine, cosine, and tangent. So I'm going to spend a little bit more time on these. Then we also have exponential functions. Exponential functions are any function where you have f of x equals some number, let's call it a, times some number b to a power, we'll call it x. So x is the variable, remember, and that means your variable in exponential functions is in the exponent. So with power functions, the variable is the base and the exponent is constant. On the exponential functions, your base is constant, but your power changes. And then we also have logarithmic functions. Logarithmic functions are the inverses of exponential functions. These are things like the log base b of x. So these would be your logarithmic functions. And they're just the inverses of the exponential functions. Together, the trigonometric, the exponential, and the log functions are what we call transcendental functions. They're functions that cannot be represented as algebraic. They're not algebraic functions. In other words, we can't make a power function become a log function. There's no way to actually combine those with addition, subtraction, roots to make it into a log function. So there's no way to make transcendental functions into these algebraic functions that we've seen before. And so we're seeing log functions, exponential functions, trig functions, and a whole bunch of other functions we've not seen. In the news lately, they've been talking about flattening the curve. That's actually what we call a logistic function. It's also not, it is a transcendental function. It's not algebraic. So there's a whole bunch of functions that exist in the world that we look at that are what we call transcendental functions. And understanding all the functions is what you need to do for this section. This is the important thing in calculus, is understanding of what a function is and what the different functions we have.